Good morning, this is Kavi Priya, Assistant Professor EC Department. I am going to discuss about the topic Norton's Theorem from the subject Circuit Analysis and Devices. First, we can see what is the statement for this Norton Theorem. So, Norton Theorem is one of the networks theorem it states that any two-terminal linear network or circuit which has a number of sources and can be replaced by the single source in parallel with the resistor, and it is known as a Norton's equivalent circuit. So the Norton's equivalent circuit consists of a single source, current source in parallel with the resistance. So this is the Norton's equivalent circuit. So any two-terminal linear circuit, when we apply in Norton's theorem to any two-terminal linear circuit, will be arrived with the Norton's equivalent circuit, which consists of the current source IN in parallel with the resistance RN, and will be having a load connected across it. This IN is nothing but it is a Norton's current, and RN is a Norton's resistance. So any complex circuit can be converted to a simpler circuit using this Norton's theorem. So after applying, we will be getting an equivalent circuit which consists of a current source in parallel with the resistance. So next we are going to discuss about what are the steps involved in the Norton's theorem. First thing is that we have to consider the circuit diagram by opening the terminals with respect to which the Norton's equivalent circuit is to be found. After opening the terminals, we have to short the two open terminals of the circuit to find the Norton's current IN. And after that, we have to find the Norton's resistance Rn across the open terminals of the circuit by considering a step 1 by eliminating the independent sources that is present in the circuit. If it is a current source, we have to open circuit it, and if it is a voltage source, we have to short circuit it. So this calculating the Rn is same as that of calculating the RTH in the Thevenin's theorem. And next we have to draw the Norton's equivalent circuit by connecting the Norton's current IN in parallel with the Norton's resistance Rn. And now we are going to apply the steps involved in the Norton's theorem to the example shown in this. So here we have to, first thing is that we have to remove the load resistor RL, which is the 50 ohms, and we have to open circuit it, and after that we have to connect this open circuit terminals to find this IN. And when we apply the mesh analysis, we will be getting the value for this IN as 10.7 amperes. And next is that we have to calculate this RN terminal, RN. For calculating the Rn, we have to remove the load resistor, and we have to open circuit the current source and close circuit the voltage source. And we have got the value for this Rn as 55 ohms. After that, we have to draw this Norton's equivalent circuit, which has a current source in parallel with the equivalent resistance, and will be having a load resistor across it. We have got the value for this IN as 10.7 and Rn as 55 ohms, and load resistor value is 50 ohms. This is a Norton equivalent circuit. Next example, we have to find what is the current that flows through the load resistor. Here our 3 ohms is a load resistor. What is the current that flows through the load resistor? We have to apply the Norton's theorem, and finally we have to find what is the current that flows through the 3 ohms. First thing is that we have to, for calculating the Rn value, we have to remove the load resistor, and we have to open circuit the current source and close circuit the voltage source. Here we have two voltage sources. We have shorted this voltage sources, and we have removed the load resistor. And when we the equivalent resistance is nothing but the 6 ohms is connected in parallel with the 1 ohm. So we are getting this Rn value as a 0.857. And next step is that we have to find the Norton's current. To find the Norton's current, we have to remove the load terminal, and we have to short circuit the terminal AB, and we have to find what is the current that flows across the terminal AB. So in this circuit, we have to find what is the current that flows across the terminal AB, which is nothing but it is a Norton's current. So here the current I1 and I2 both flows across the terminal IN. So first we have to find I1, and next we have to find the current I2. So I1 is nothing but, it is nothing, V is equal to IR, I is equal to V by R. So the voltage source here is nothing but 20 volt, the resistance R1 value is nothing but it is a 6 ohms. So 24 divided by 6 is the value for I1. And for calculating the I2, I is nothing but V by R. I2 is equal to V2 divided by R2. So V2 value is nothing but 12 volt divided by R2 value is nothing but it is 1 ohms. So 12 divided by 1. So IN is nothing but sum of I1 and I2. So 24 by 6 plus 12 by 1, which is nothing but it is a 6 ampere, which is the current IN. Next step is that you have to draw the Norton's equivalent circuit, which has a current source in parallel with IN in parallel with the RN, and we have to connect the load resistor across it. So we have got the IN value as 16 ampere, RN value is 0.857 and the load resistor R3 is nothing but it is a 3 ohms. In question they have asked to find what is the current that flows through this 3 ohm resistor. So to find this current IL that flows across this 3 ohm resistor, we have to apply the current division rule. IL is equal to IN into RN divided by RN plus RL. So this IN is a Norton's current we have found in the previous step, and RN is also it is a Norton's resistance we have found in the previous step, divided by RN plus RL. So here the IN value is 16 ampere into 0.857 divided by 0.857 plus 3 ohm. RL value is 3 ohm. So after applying this current division rule, we will be getting the answer as 3.55 ampere. This is the current that flows across the resistor 3 ohms. If we require voltage, V is equal to IR. So this current 3.55 into 3 gives the voltage that is available across this particular 3 ohms resistor. So this is a step involved in solving a circuit using a Norton's theorem. First we have to calculate this IN and next we have to calculate this RN. For calculating the IN, we have to remove the load resistor. We have to remove the load resistor and we have to short circuit the terminals of the load resistor. And we have to find what is the current that flows across this open terminal. And next is we have to find the RN, we have to remove the load resistor and we have to short circuit the voltage source or open circuit the current source. After that we can find what is the value of RN. So after finding this IN and RN, we have to draw the Norton's equivalent circuit. So it consists of the current source IN in parallel with the resistance RN and we have to connect the load resistor across it. In question, if they ask to find what is the current that flows to the load resistor, next we have to apply this current division rule. IL is equal to IN into RN divided by RN plus RL. Through it, we can calculate what is the current that flows across the load resistor. And if we require what is the voltage available across the load resistor, V is equal to IR. So this current IL into corresponding resistor value 3 gives you the voltage available across the resistor 3 ohms. Next is the assessment question. Norton current is a short circuit current. And next is a Norton's theorem is true only for the linear networks. And Norton resistance is found by shorting all the voltage sources and opening all the current sources. So that's all about the Norton's theorem. Thank you.